Today we're going to be talking about two-way tables and Venn diagrams. Last class, we talked about mutually exclusive events. Events A and B are mutually exclusive if they cannot both happen at the same time. So if that's the case, then the word or, when we're talking A or B, means that either only event A happens or only event B happens. So we had the addition rule for mutually exclusive events. Probability of A or B equals the probability of A plus the probability of B. But if A and B are not mutually exclusive events, then A or B means either A happens or B happens or possibly both happen. This does make our calculation a little bit more complicated, but using a two-way table can help make it a little bit clearer. So for our first example, students in a college statistics class wanted to find out how common it is for young adults to have their ears pierced. They recorded data on two variables, gender and whether or not the student had pierced ears, for all 178 people in the class. The two-way table summarizes the data. Here's the two-way table. You can see we have gender at the top, whether or not the student has pierced ears on the left, and this table conveniently includes the totals. Some two-way tables do not include the totals, so you might need to figure those out yourself. Suppose we choose a student from the class at random. Define event A as getting a male student and event B as getting a student with a pierced ear. Find probability of B and interpret this value in context. So probability of event B, we are looking at what is the probability of selecting a student with pierced ears. So if you look at the table, total, there are 103 people with pierced ears. Out of the total, 178. If you divide those, you get 0.579. If we are interpreting this in context, we need to just write a sentence that includes this probability and what we're talking about. So the probability of a randomly selected student having pierced ears is 0.579. Next, we want to find the probability that a student is both male and has pierced ears. So males with pierced ears, there are 19. Out of the total, 178. If you divide that, you get 0.107. Lastly, we want to look at the probability of A or B. So this means the probability of selecting a student who is either male or has pierced ears or both. So if we look at the table, we have males and people with pierced ears, and this is the people who are both males with pierced ears. So if I add up all of those totals, we have 19, 84, and 71. Out of the total 178, I get 174 out of 178, which when you divide is 0.978. Now, we can't use the addition formula for mutually exclusive events to find this probability in part C. Because if we did, we would have counted the males, which there are 90 of total, counted the people with pierced ears, which there are 103, and we would have double counted all of the males with pierced ears, which there are 19 people in that category. So if you try to add up the probability of A, which is males, the probability of B, which is pierced ears, you get an answer that's bigger than 1, which, as we discussed last class, is not possible. So we need to subtract out the people who were double counted. So the general addition rule is for two events, A and B, it doesn't matter if they're mutually exclusive or not. The general addition rule says probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So this subtracts off the people who were double counted in event A and event B. This still works for mutually exclusive events because in mutually exclusive events, the probability of A and B is 0. Next, let's take a look at Venn diagrams. You probably learned about Venn diagrams in geometry, but they can be helpful when looking at probability as well. A Venn diagram consists of two or more circles surrounded by a rectangle. Each circle represents one event. The region between the two circles, where they overlap, represents A and B. The region inside the rectangle, but outside the circles, represents when neither A nor B happen. So let's take a look at how to summarize this data from the two-way table and put it into a Venn diagram. Always start in the center of the Venn diagram. There are 19 people who are both male and have pierced ears. So they go in the middle. Anyone who is male but does not have pierced ears is going to go in this yellow circle here. There are 71 people who are male with no pierced ears. Anyone who has pierced ears and is not male goes in the blue circle on the right. So there are 84 females with pierced ears. Anyone who is neither male nor has pierced ears, so females without pierced ears, goes on the outside of the circle. There are 4 people in that category. Next, let's take a look at some vocabulary related to Venn diagrams. First, we have complement. We talked last class about the complement. You have A with an exponent of C. That means all outcomes that are not in A. So in a Venn diagram, that is all of the space outside the circle. So if A is the circle, A complement is going to be the space inside the rectangle but outside the circle. Next, we have the intersection of A and B, which is another way of saying A and B. The appropriate set notation is A. This symbol means intersect B. That's represented by the overlapping parts of the Venn diagram. Then A union B is another way of saying anything that is in A or in B. The notation, we have A union B. So think U union. So that's anything that is in either circle or in both circles. So again, A and B is another way of saying A intersect B. You are looking for all outcomes that are a part of both event A and event B. In our pierced ear example, A intersect B was males who have pierced ears. A or B is another way of saying A union B. That's any outcome that is in event A or event B or both. So in our pierced ears example, that was anyone who is either male or has pierced ears or both. So we can rewrite our general addition rule using this notation. The probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersect B. So let's look at our last example. What is the relationship between educational achievement and home ownership? A random sample of 500 U.S. adults was selected. Each member of the sample was identified as a high school graduate or not, and as a homeowner or not. We have a two-way table to display the data. Suppose we choose a member of the sample at random, and let's define event G as someone is a high school graduate and H, someone is a homeowner. First, we want to explain why the probability of G or H is not equal to the probability of G plus the probability of H. Well, that is the addition rule for mutually exclusive events. So are the events high school graduate and homeowner mutually exclusive events? No. There are quite a few people who are both high school graduates and homeowners. Now we want to find the probability of G or H. Since we know that G and H are not mutually exclusive, that means that we can find this probability by doing the probability of G plus the probability of H minus the probability of G and H. It would be helpful if our two-way table had some totals, so I'm going to go ahead and add those. So now, the probability of G, so being a high school graduate, is 310 out of 500. The probability of being a homeowner is 340 out of 500. The probability of being both a high school graduate and a homeowner is 221 out of 500. So if I go ahead and do that math, I get 429 out of 500, which if you divide, gives you 0.858. Now, we want to make a Venn diagram for this situation. So I've got G and H. The number of people who are both high school graduates and homeowners goes in the middle. High school graduates who are not homeowners go in the left circle. Homeowners who are not high school graduates go in the right circle. and people who are neither homeowners nor high school graduates go outside the circles. Lastly, we want to write the event is not a high school graduate but is a homeowner in symbolic form. So, not a high school graduate means we have the complement of high school graduate. But means and. A homeowner. So, if we want to find the probability that someone is not a high school graduate but is a homeowner, they're a homeowner, so we know that they're going to be in the right-hand circle, but they are not a high school graduate, so they are not in this middle part. They are only in the right circle, not in the left circle. So if we wanted to find this probability, that would be 119 over 500, which is 0.238.